Today I made a two-stage amplifier with voltage gain of about 1000. So first of all, because I wanted to test this amplifier for input voltage of the range about 1 millivolt peak to peak, but my function generator couldn't generate this amount of a small voltage. I needed a voltage divider circuit as follows, so that I can generate 2 millivolt peak to peak from 100 millivolt peak to peak. So from here I get the 2 millivolt thing, and after that I have two LM741 op amps, differential amps. They are in inverting mode, so their gain is going to be this amount, and they're going to be multiplied because we have two op amps cascaded to each other, and these are the values. In the designing, we normally have to try to get the more gain from the first one, and then the second one is a little bit less. That's the reason I choose RF1 bigger than RF2. And in total, the total gain is going to be something around this much. And these are the pinouts for the LM741. The pin 8, which is not connected, pin 1, which is the offset node, and pin 5, which is the offset node again, they're gonna be floating. Pin 7 is gonna be connected to the supply voltage, 15 volts for me, and pin 4 is for the negative one of that, for the supply. Because they are in inverting mode, the non-inverting will be grounded, and the inverting is gonna be connected to our circuit. And after that, we're gonna get about 1000 gain, so that the 2 millivolt voltage becomes something around 2 volt peak to peak. Just something that I did not put any coupling capacitor or bypass capacitor, so I did not analyze its frequency response. But the input frequency, the frequency of the signal is around 20 Hertz. So this is a circuit based on the picture that I show you, and what the other thing is, when we have cascaded op amps, just as here that we have two stages, we have to consider the loading effect of the second stage and the first stage, because it can change the gain that we desire. And the input gain for this non-inverting thing is gonna be the R2 and the R1 for the first one. So in this case, because R2 is very smaller than the RF, the loading effect is gonna be negligible. So what I want to mention in here is that when we are designing, the way that we choose R1 and R2 is based on the loading effect. And this is the input that I give, and then after that, with this voltage divider is gonna be the real input of my signal, and the frequency is 20 Hertz. This is gonna be, if I choose the cursor as source 1, this is gonna be the input to the circuit. Let me make it a stop so that you can see it better. It's something around 2 volts, right? And then it's gonna be our output. Which is amplified to 2.3.